black holes were considered a theoretical construct. And Einstein even denied their existence in 1939. But then, in the mid 1960s, quasars were discovered. These are very bright sources of light, 100 times brighter than their host galaxy, which are point-like at the center of galaxies. And it was immediately suggested by Ed Salpeter in the West and by Yakov Zeldovich in the East that these are black holes that accrete gas, collect gas from their host galaxy, that are being fed with gas. And they shine very brightly because as the gas falls towards the black holes, just like water, running down the sink, the gas swirls and then rubs against itself and heats up and shines very brightly because it's very hot close to the black hole. By viscosity, it heats up. And in the case of black holes, it's the turbulent viscosity that causes it to heat up. So we get these very bright sources of light just from black holes that are supposed to be dark. Mm-hmm. Nothing escapes from them, but they create a violent environment where gas moves close to the speed of light and therefore shines very brightly, much more than any other source in the sky. And we can see these quasars all the way to the edge of the universe. So we have evidence now that when the universe was, about 7% of its present age, infant, yes. Already back then you had black holes of 1 billion times the mass of the sun, which is quite remarkable. It's like finding giant babies in a nursery. How can these black holes grow so fast? Less than 1 billion years after the Big Bang, you already have 1 billion times the mass of the sun in these black holes. And the answer is presumably there are very quick processes that build them up.
They build quickly.
Very quickly. And so we see those black holes, and that was found in the mid-1960s. But in 2015, exactly 100 years after Einstein came up with his theory of gravity, the LIGO Observatory detected gravitational waves. And these are just ripples in space and time. So according to Einstein's theory, the innovation, the ingenuity of Einstein's theory of gravity that was formulated in November 1915 was to say that space and time are not rigid. They respond to matter. Mm-hmm. So, for example, if you have two black holes and they collide, it's just like a stone being thrown on a surface of a pond. They generate waves, disturbances in space and time that propagate out at the speed of light. These are gravitational waves. They create a space-time storm around them, and then the waves go all the way through the universe and reach us. And if you have a sensitive enough detector like LIGO, you can detect these waves. And so it was not just the message that we received for the first time, gravitational waves, but it was the messenger. So there are two aspects to it. One is the messenger, which is gravitational wave, for the first time were detected directly. Yes. And the second was the message, which was a collision of two black holes, because we could see the pattern of the ripples in space and time, and it was fully consistent with the prediction that Schwarzschild made for how the space-time around the black hole is, because when two black holes collide, you can sort of map from the message that you get, you can reconstruct what really happened, and it's fully consistent.